All right, starting off here on number 1, so we want to write a point or write a formula here that has this vertex and then has this point. So our vertex form is always y equals a times x minus h squared plus k. And so we want to go ahead and plug in our vertex point as h comma k. And I'm going to leave a as a variable, and so I'm going to put x minus 4 here. And so even though that h value is 4, it's kind of always the opposite when you put it in here. We say like x lies to help remember that. And then the plus k out back, that's negative 4 since that is negative. All right, so then to find out what a is, we're going to need to use this other point as x comma y. So I'm going to plug that one in for x. And I'm going to plug 32 in for y, and then I'm going to plug 1 in for x, like so. So now I need to work to solve for a here. So I'm going to go ahead and do some PEMDAS. So I have negative 3 squared minus 4. And then we get 32 equals 9a minus 4. We'll add the 4 over. And so we get 36 equals 9a, and then divide by 9. A equals 4. So I can just kind of go back and really like scribble this out here on my first step and plug in a 4 right there, and then I can see that the answer is A. All right, next up here we're trying to factor this as the difference of two perfect squares. I see that 64 and 9 are perfect squares and they are subtracting. So anytime we do this, we kind of just take the square root of everything, so it's going to be 8x and 3. And then for the difference of perfect squares, it's always 1 plus and 1 minus, and that's it. All right, this one we want to solve by factoring. However, I see that we can take a 2 out front first, so I'm definitely going to do that. Oh, but I have to divide everything by 2. So we get 2x squared plus 5x minus 3 equals 0. So now I would just do the x box with the factoring with the inside. So a times c would be negative 6 and b would be 5. Remember, we do need the grouping here, so I'm going to let you guys take it from here. You can really actually just ignore this 2 out there. It's not going to be relevant for the rest of the problem since it got taken out front. All right, next up here, we're going to find the missing value to complete the square. So completing the square is always where we add b over 2 squared to both sides. So in this case, that'll be 6 over 2, and then we square that. So that's 3 squared, which is 9. All right, next up, we want to find a function here. So we first want to identify what type of function it is. So I can check and see if it's linear by checking the pattern here for plus. So I got plus 1, plus 2, and plus 4, plus 8. So that's not correct. So it's not the same, so it's not linear. And then if I check the next level, plus 1, plus 2, plus 4, I also see it's not quadratic. And so it's probably exponential. So I see that the pattern here, if I kind of did it the other way as multiplying, would be times 2 on the y values times 2 on the y values. So that does mean that it's exponential. It also means my base is 2. Exponentials are always in the form y equals a times b to the x, and b is really what's multiplying as we go along. A is always kind of the y-intercept. It's where the y value in x is 0, so a is 1. So I'm going to say y equals 1 times 2 to the x. And I'm going to say the answer is B. They didn't put the 1 there because it's multiplying 1. It's irrelevant. All right, next up here, number 6. We're going to solve this one. So I'll do, actually, we'll try to factor it, thinking of two numbers multiply to 4 and add to 6, but no numbers work. So I'll jump into quadratic formula. So negative b, I'll write it up here. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So we have negative 6 plus or minus the square root of 6 squared minus 4 times 1 times 4. That's all over 2 times 1. So now I have negative 6 plus or minus the square root of 36. And then I'll multiply these. So that's negative 4 times 1, which is negative 4, times actually a positive 4. So that's going to be a negative 16. It's still all going to be over 2. So now I have x equals negative 6 plus or minus rad 20 all over 2. And we'll break that down. It's 4 and 5, which will break down to 2 and 2. So we'll have twin 2's going outside. So we have negative 6 plus or minus 2 rad 5 all over 2. And we'll just reduce it here with the heart. So we get negative 3 plus or minus radical 5 all over 1. We don't need the all over 1, so I see the answer is A. All right, next up here, we're going to write a function for these. So we're just going to track the y values here. We're going to check addition first, and it looks like we do have a constant addition here. And so that tells me it's going to be linear. And so, and it also tells me that m is going to be 5. That pattern, that number that's adding or subtracting, is our slope. And so then I'm going to find, I know it's y equals mx plus b. So I do need b. B is always the y-intercept, the y value when x is 0. So that happens to also be 5. So I'm just going to say y equals 5x plus 5. All right, next up, this one says to solve the equation. I never like solving it with a negative x squared, a negative a value. So I would actually move everything over to the right side, which would switch all of the signs. And then I would do an x box to factor. And once again, you have to do grouping here. So I'll let you guys try that. All right, next up here, they want us to find the vertex and the y-intercept. This is in vertex form, so it's going to be really easy to find the vertex. So that'll be -3, 4. So I can already tell it can't be C and it can't be B. It's got to be either A or D that have that vertex. The y-intercept, though, is not so easy. We have to actually plug in 0 for x and solve. So I'm going to go ahead and do my PEMDAS here. So I have 3 squared plus 4. All right, and so we get y equals -18 plus 4, and that's -14. All right, next up here, number 10. So we're going to solve this one. I would actually first divide everything by 5, or you can do this kind of at any point here, but I would then switch that to x squared plus 8x equals -4. And so now I would add the 4 over to this side, get one side to 0, to use quadratic formula. All right, so let you guys try the quadratic formula there. All right, next one here, they're asking which is a factor of this. So I'm going to go ahead and factor it. So we're thinking of two numbers multiplied to 40 and add to 14, so that's 10 and 4. However, since we have this 5x squared out front, we do need to use grouping. So I'm going to split this up as plus 10x and plus 4x, and then plus 8 out there. So now I'm going to group these together. In the first group, I can take out 5x, which leaves me with x plus 2. Second group, I can take out a positive 4, which leaves me with x plus 2 as well. So then my parentheses are going to be 5x plus 4 and x plus 2. Now this is not equal to 0, so I'm not going to split this up. And also it just asked me for the factors, so I'm just going to see which one is there, and we can see that x plus 2 is there. All right, next up we want to write this one in vertex form. So if I'm switching to vertex form, I would, first of all, I would just find the vertex. So that would be negative b over 2a. So in this case, that'll be negative 16 over 2 times 4. So that's negative 16 over 8. So that'll be negative 2. And I need to plug that back in to find y here. All right, so now I'll do some PEMDAS. So I'll do my exponent first. So that's going to turn into positive 4. And now I'll do my multiplication. So this will be 16 minus 32 plus 19. So 16 minus 32 is negative 16. Plus 19 would be 3. So my vertex is negative 2, 3. So that should be, let's see, that's got to be A here. You can see they switch the x value in there and then keep the y value of the vertex out there in the vertex form. A should always match up here, that 4 with the 4, and you can see that it does. All right, number 13 I'll let you guys do. We did one of those earlier with completing the square. I'll go ahead and do number 14 here, so you use the vertex form to write the equation. So I see the vertex here is at -3, 5. And so I would say that A and C are wrong. We need that plus 3 in there and then the plus 5 out back since x lies, but y tells the truth. However, I notice that this one right here is a positive a value while this one's a negative a value. So with that, I know that the answer is B because the negative a value means that it's going to be an upside down parabola, whereas a positive a value would mean it's a right side up. All right, next up here, number 15. So on this one, we're going to use substitution. So I see that y is isolated, so I'm going to take this right there and move it over there. So we get x squared equals x plus 2. So I need to get one side to 0, so I'm going to subtract x and subtract 2 from both sides. So we get x squared minus x minus 2 equals 0. So now we'll factor this, thinking of two numbers that multiply to -2 and add to -1. So that would be -2 and positive 1. You could use the grouping technique here, but since I don't have the value in front, I actually can skip that and just put those numbers in my parentheses. So then I would set these equal to 0. So x minus 2 equals 0. So x equals 2. And then x plus 1 equals 0. So x equals, minus 1, and x equals negative 1. All right, now since this is a system, I do have to plug these back into either equation. I'll go ahead and use this one. It looks a little bit easier. They're pretty close. It doesn't matter. Whichever one you think is easier, we have to plug these x values in and get our y values. So this one is 2, 4. And then for this one, it would be a negative 1 plus 2, so y equals 1. So I plugged in a negative 1 and got out a 1. So those would be the points I'm looking for. So that's looking like a D. All right, next up here, solve the equation. So we have no b value, so I would just isolate the x squared. So that'll be x squared equals 96, and then we'll square root both sides. Now, since I created that square root, I have to put a plus or minus in front of this. And then I got to break down 96, so I know it's even, actually, but it looks easily divisible by 3. So I'm actually going to use 3 and 32. And then 32 I know is 8 and 4, and that's 2 and 4. And I can actually stop right there since I have twin 4s. You can keep going if you want to break those down, but if I see twins, I stop them. And then the 2 and the 3 are going to be loners on the inside. Number 17, same idea here. I'm going to break this down. There's no plus or minus since I didn't create that square root. It was already in the problem. But you just break it down like we did on number 16. All right, next up, number 18. To solve this one, I first want to divide this negative 5 over to the other side. That'll cancel out. So I get x plus 5 squared equals 2. Let's square root both sides. So x plus 5 equals plus or minus rad 2. Then I'll subtract 5 from each side, so I get x equals negative 5 plus or minus radical 2. All right, next up here, we're going to check our y values. And so I see here it's plus 10, and then plus 30, and then plus 50, and then plus 70. And I'm just going to stop right there. You can see it's not linear because those are not consistent. However, I do notice that if I went to that next level, it would be a consistent plus 20. So that's good. So that means that it is quadratic. And for quadratic, our equation is always y equals ax squared for these problems. And so to find that a value, I'm just going to plug in any point except 0, 0. So I'm going to use this one, x comma y. So we get 10 equals a times 1 squared. So 10 equals a times 1. So then really a is 10. So then I can say y equals 10x squared. All right, next up, number 20, we're going to solve this by substitution, but I need an isolated variable, so I'm going to go ahead and subtract this x squared over to this side. So I get y equals negative x squared plus 13. And so then I'm going to take that, I'm going to put it in parentheses, and I'm going to swap it out for the y here on the other one. So that's our goal when we isolate the variable, is to swap it out on the other one, on the other equation. So I'm going to say 3x minus 2, and then instead of y, I'm going to say negative x squared plus 13 equals negative 12. So now I need to distribute this negative 2 here. So I'm going to say plus 2x squared minus 26x. Actually, not 26x, just minus 26 equals negative 12. I need to get one side to 0, and then I need to rearrange it into standard form. So I'm going to put 2x squared first, and then 3x, and then minus 14 equals 0. So now we're going to factor this. We're going to think of two numbers that multiply to negative 28 and add to 3. So that's negative 7 and 4. Actually, no, it's positive 7 and negative 4. Since we need to add up to the positive, the bigger one's got to be positive. And so then I need to use my grouping here. So I'm going to split this up as 7x and negative 4x. And then I got here 2x plus and then minus 14. So the first group, actually this is 2x squared. The first group I can only take out an x, which leaves me with 2x plus 7. The second group I can take out a negative 2, which will leave me with 2x plus 7 as well. So then I know x minus 2 times 2x plus 7 equals 0. So then to split this up, x minus 2 equals 0, and 2x plus 7 equals 0. So then I have plus 2, x equals 2, and then minus 7, 2x equals negative 7, and then x equals negative 7 over 2. So those are my two x values, but I need y values as well. So what I'm going to do then is I'm going to take those and I'm going to plug them back in wherever is easiest. So where is the easiest? I'm going to plug them into the 3x minus 2y equals negative 12 one. So instead of that, I'm going to put 3 times 2 minus 2y equals negative 12. And so 6 minus 2y equals negative 12. I'll subtract the 6. Negative 2y equals negative 18. Divide by negative 2. And y equals 2. So when I plug in a 2, I get back out a 2. And now I need to plug in the negative 7 over 2, but I'm going to need some more space for that. All right, so we'll do 3 times negative 7 over 2 minus 2y equals negative 12. So this will be 3 over 1 here. So I can't cross cancel, but I get negative 21 over 2 minus 2y equals negative 12. I'm going to add 21 over 2 to both sides. So I need to do negative 12 over 1 plus 21 over 2. That's going to require a common denominator, so I need to multiply this by 2 over 2. And I get negative 24 over 2 plus 21 over 2 equals negative 3 over 2. So let me get some more space. All right, so now I get that as negative 2y equals negative 3 over 2. And then I'm going to divide this side by 2. But on this side, instead of dividing by 2, I'm actually going to multiply. Oh, it's by negative 2. I'm going to multiply by negative 1/2, which is really the same thing. So I get y equals 3 over 4. And so that point will be negative 7 over 2, comma 3 over 4. Next up here, we need to first divide this by 3 to solve. So we get x squared equals 9. And then we'll square root both sides. And then we get x equals plus or minus 3. All right, next up here, it's going to ask us about this parabola right here. So we got to find the vertex first. So the vertex is always x equals negative b over 2a if you're in standard forms. This one will be 8, positive 8, since it's negative 8 over 2 times 1. So that's 8 over 2, so that's 4. And then my y value will be 4, the x value squared minus 8 times that x value plus 9. So that's going to be 16 minus 32 plus 9. That'd be negative 16 plus 9, which is negative 7. So I know my vertex then is 4 comma negative 7. My axis of symmetry is always x equals the x value of the vertex. My y-intercept is always this last number on the standard form, so it's just 9. And then is the vertex and minimax value. I kind of need to look at a here. So a is positive, and so that means it's going to be an upward-facing parabola. So I'm just going to visualize that. I like to draw a little picture. I know my vertex is 4 comma negative 7. So I would say that that's the min value, because you can see it's the lowest point on the graph. And then the min value itself is negative 7, since that's the lowest point on the graph. All right, last up we got number 23. So that one you're going to get one side to 0 and then either factor or use quadratic formula.